I really wanted to introduce the concepts of angular resolution, visual acuity, and diffraction as they apply to the horizon, so that these laws of physics, light, resolution, and perspective can be taken into account and hopefully further developed in order to better understand our Earth and also to help dispel some of the tired old myths. So to begin, what is angular resolution? Angular resolution describes the ability of any image-forming device, such as a telescope, microscope, camera, or the human eye, to distinguish small details of an object. It is the minimum angle needed so that an instrument can discern resolvable detail, and it represents the resolving power and precision of optical instruments, which includes the eye. This angle is created at the eye or the lens, and it is based on the diameter of an object and that object's distance from the observer or the device. This angle determines the size of the image that is projected onto the retina. So once an angle is small enough that it reaches the angular resolution limit, no image can be resolved on the retina, and basically the object disappears. The formula to find the angular resolution of the human eye or any image-forming device is the constant of 1.22 times the wavelength of light divided by the diameter of the lens aperture or entrance pupil. Once you figure out the angular resolution of, say, the human eye, you can then determine how large or how far away an object must be for you to be able to resolve it. In other words, for you to be able to see it. This is the limit of eyesight, or the resolving power of a telescope, camera, or microscope. Anything beyond this limit cannot be seen. A shorter distance and larger diameter of an object equal a larger angle at your eye, thus easy to resolve. A longer distance and smaller diameter of an object equal a smaller angle, thus difficult for your eye to resolve. The size of the angle is also what gives us perspective. Objects do not physically shrink in size as they move away from us, but the angle in our eye gets smaller and smaller, which is what allows us to determine that it is moving further and further away. For objects coming toward us, the angle will get larger and the object will appear to be larger on the retina. This is an important part of perspective. This is how we distinguish objects moving away versus coming toward us. The angles also help us determine the size or distance of any given object. Visual acuity is another closely related term that means clarity of vision or the limit of one's eyesight, and it is a measurement of the angular resolution of the eye or the device. The generally accepted value for the angular resolution limit or visual acuity of the human eye is about 1 arc minute, which equals 0.02 degree. This means that at a distance of 1 kilometer, the human eye can resolve an object that is about 30 to 60 centimeters in diameter. Beyond this, the angle formed in the observer's eye gets smaller than 1 arc minute, and the object will blur and then finally disappear altogether. The main reason I want to introduce these concepts is to demonstrate with logic that there are scientifically proven and verifiable factors that determine how far we can see with our own eyes and with telescopes. Angular resolution equations are used by NASA, astronomers, and scientists to determine the resolving power of the human eye, cameras, microscopes, and telescopes. So when people say, if the Earth was flat, then we should be able to see Europe across the ocean, there are scientifically proven laws of light, diffraction, resolution, and perspective due to the resolving power of our eyes and even the most powerful telescopes. We could never possibly see across an ocean that is thousands of miles in distance. It is impossible due to the laws of physics, due to the physics of the angles, not to mention the additional limitations of diffraction. However, the mistaken or disingenuous conclusion put forth by the so-called scientific community In spite of these scientifically proven and accepted limitations on light propagation and resolution, is that the reason we can't see across the ocean is because we live on a spinning ball. This assertion of boats going over the edge of a ball Earth is silly. Check out this footage from a channel called Wide Awake. This guy filmed some great sky and horizon shots showing that objects can be brought back into view, and more importantly, his shots also demonstrate diffraction and the resolution limit of these objects at those distances and at those angles. As you can see in his footage, the boats, once they are close enough to resolve, appear like little smudges, and they also appear to be floating above the horizon. The boats are not mirages floating in the air, although there is an inferior mirage that appears inverted below the actual boats in his footage. To prove this, he actually tracks them all the way in, and the closer a boat gets, the more resolved it becomes, and the more detail you can see. This is a perfect illustration of visual acuity and the angular resolution of the camera, which is obviously better than our eyes, but the principle is the same. And again, if you increase your altitude, say to the top of a hotel or in an airplane or on a mountain, you create better angles and you can of course see further, but even there you will eventually reach a resolution limit. It is unavoidable. Look at the water in his shots. Some would call the resolved water line the horizon, but you can clearly see boats fully in the water beyond the resolved water line. You can even barely make out the water being sprayed up from the motor. The surface of the water extends beyond the resolved water line, but it is too far and at too sharp of an angle for the camera or your eye to completely resolve. There's also a lot of diffraction going on due to this angle and the light or atmospheric conditions. Therefore, you get a blurred section that reflects the sky and the boat as an inferior mirage. Again, this happens beyond a point where the eye or camera can no longer clearly resolve the water due to the angle and diffraction. It is where your eye or camera can no longer distinguish points of light. The image blurs and turns into a mirror under certain conditions. Look at the shimmering and changing edges of the top of the waterline as the camera resolves it at its maximum distance. Beyond this distance, the water is at too small of an angle to resolve any detail. At this point, it does exactly what a road will do on a hot day. It reflects the light waves like a mirror because the eye or camera can more easily resolve these reflected light rays than they can the actual surface of the road or water. On the ground or on the water, you can see the inferior mirage or reflection of the boats and cars. Some people will claim that the boat itself is a superior mirage and that the actual boat is over the edge of a ball. This is silly for two reasons. Number one, a superior mirage is inverted, and number two, in this footage, he tracks these boats the entire way in, so you can verify with your own eyes how a boat will barely come into view as a small blur, and then as it gets closer and closer, the angles get larger and your eye can then resolve more and more detail. This is observable, repeatable, apparent, and can be verified by anyone. I would like to discuss the issue of boats or buildings being cut off by the horizon line over water. The hotel is not obscured by the edge of a magic ball. It is simply perspective and angle of view. The limit of what I can see above and below my eye level converge at what we call the horizon line or vanishing point. So check out this little experiment I did. In order to simulate the size and distance of that hotel, I took a small glass bottle and put it on the road and then filmed from ground level. Now the hotel is about 18 stories, which equals about 180 to 200 feet. I used 250 feet just to be conservative and to give it some room above the actual water line, and the distance is 17.5 miles. The glass bottle is 3.5 inches, so that meant that I would have to put it at a distance of about 107 feet to get the same ratio. Now, when I started filming, I was standing up and I could zoom in on the bottle, the entire bottle, top to bottom, and then I pan out, I take the camera and I place it on the ground. And even on the ground, it's actually conservative because the lens of the camera is still about 1 inch to 1.5 inches above the ground. So this is a conservative experiment. And when I zoom in, you can see now that the angle of resolution is just too small, and combined with the diffraction, you cannot make out the bottom of the bottle. It disappears. It is cut off. And that is exactly what you're seeing in those pictures and videos where buildings or boats are cut off at the bottom. Your eye cannot resolve the detail of the surface of the ground or the bottom of that bottle. It's just too sharp of an angle. And you can even actually see beyond the bottle where the road is, again, the same color, because your eye can resolve that a little bit better because it makes a curve and the angle is a little bit better on the road beyond where the bottle is. So that's a pretty interesting little experiment and shows you the effect of diffraction and angular resolution. And again, even on the ground, the lens of the camera is about 1 inch or 1.5 inches off the ground, which when you compare that to the bottle, that is almost half of the bottle. So that would probably equal an observer that is about 100 or 150 feet in the air filming the hotel in New Smyrna. So if I was actually on the ground with the camera, I'm sure that the diffraction would probably cover almost the entire bottle, if not half the bottle, and it would look exactly like the waterline covering these hotels or these boats. But you can see the principle. If I'm standing on the beach at sea level, then obviously my field of view from my feet to the horizon will be much shorter due to the angle. Again, about 3 miles from the beach is approximately the limit for a 6-foot tall individual. Yet the distance of my field of view above the horizon will be much greater due to the angles. Therefore, I can see most of a hotel 18 miles away, but again, not the bottom of the hotel due to the angular resolution and the angle of perspective. The same principle applies to a sunset or a sunrise. The waterline horizon at the beach is about 3 to 4 miles out. Yet the sun is thousands of miles out when it disappears due to the limit of angular resolution and light propagation. We can see the sun at a much further distance because it is so large and high in the sky. But just like anything else, once it gets far enough away from the observer, the angle becomes so small that it will disappear, the furthest edge first, appearing to go down behind the water. This is what you would expect to see based on perspective. Something closer will appear in front of something farther away. It simply vanishes at the waterline horizon due to perspective. Even the sun is subject to the laws of perspective, angular resolution, and diffraction. With a sunrise, it is the opposite. We see the top of the sun first because it is approaching us. Therefore, the side that is coming toward us is the first section of the sun to come into our field of view due to angular resolution. And again, due to the laws of perspective, the sun will always appear to be behind the much closer waterline. So we look to supposedly qualified authorities to study these issues for us and provide reliable explanations. For hundreds of years, the scientific authorities, now the space agencies, have both knowingly and unknowingly filled this gap with their own cleverly constructed explanations. One way they fill this gap is to use the angular distance of a sky object to invent their model. The angular diameter, or apparent size, is an angular measurement describing how large an object appears from a given point of view. For example, this involves looking at the sky and determining that the sun and moon have an angular diameter of about 31 or 32 arc minutes, which equals 1/2 of a degree. So this is the angle created in our eye or in a telescope, which means that the sun and the moon can be around 31 miles in diameter and 3,500 miles up, or, as the authorities claim, the moon can be 2,159 miles in diameter and 237,000 miles away. And they claim the sun is 864,575 miles in diameter and 93 million miles away. You see, both measurements are correct based on the angle we see from Earth. Knowing the angular diameter or apparent size of a celestial body, we can easily invent a model using trigonometry. We could say the sun is 500 miles in diameter and 57,000 miles away, or maybe it is only 5 miles in diameter and 500 miles up. Or if we wanted to get really crazy, we could invent a sun that is 2 million miles in diameter and 229 million miles away. Of course, if we did that, we would then have to adjust all of the diameters and orbital speeds of the planets and distances, but this should give you an idea of how they have constructed their model, because they are all built on apparent sizes, the angular diameter of lights in the sky visible from Earth. So, relationally, the math works out. They then construct their universe model around these angles, filling in and changing the numbers as needed to fit their assumptions.